Welcome back, ladies and gentlemen. In this video, we are going to go over hedging a long position with a future contract, and we're also going to talk about optimal contracts to get into to hedge the best as possible. In our first example, we are going to hedge a long position, meaning that we have a farmer that has 2 million pounds of cattle, just a bunch of cows. And the sell time or the ideal time to go ahead and take the cows to sell them would be in about 3 months from now. And well, the price can change. And the farmer will like to minimize that fluctuation and be able to have a better idea of the money that they can count on 3 months from now instead of taking the risk. So they look into future contracts. Now, future contracts are not going to have exactly 2 million pounds, but they may have 3 months exactly. Not always happens, but for this example, we can assume there's a good match in the contracts out there. So the farmer finds that there are future contracts on cattle. Each contract, it covers 40,000 pounds. It is for 3 months, which is desired because it matches the time frame. And the future price is $1 per pound. That's the price the contract says. That means that if you get into this contract, you agree at a price of $1, regardless of what the market price is. So the first question is, since this is a long position where the farmer is going to sell the product to then make a profit if the price goes up, then what you want to do, you want to do the opposite with a contract. You want to short the contract, which is somewhat like selling. And what it means is that if the price goes down, the farmer makes less money with their cattle, but makes more money with shorting the contract. If the price goes up, the farmer makes more money when they sell the cattle, but they're going to lose some money on the shorting the contract. Now, this purpose is not to profit more. The purpose is to guarantee a certain profit. And we'll go over the numbers to show it. So first is, well, how many contracts shall we do? Well, what we do is we take the 2 million pounds that you want to cover on your hedge and divide it by the amount of pounds in each contract. So we know we got to deal with 50 contracts. All right, so let's see what happens if the farmer does not hedge. So let's say the actual price in 3 months goes to $1.15 a pound. So the live cattle value would be the $1.15 times the 2 million pounds. So the farmer can go ahead and benefit with $2 million, $2,300,000. But if the price goes down to 80 cents a pound in the future, then we have the price per pound times the pounds. The farmer is looking at $1.6 million. So what's the range between those two? The farmer has this wide $700,000 range. That represents risk. The farmer cannot tell if they're going to be able to make 1.6 million or 2.3 million or anything in between. So there could be a $700,000 difference that the farmer will not know if they're going to be able to get that, some of that, or none of that 3 months from now. And this is important for planning and understanding your cash flows. So the idea is to then try to get rid of that potential fluctuation and just have a certain number you can count on that you're comfortable with and move on. So let's see what happens when you use the hedge. So here we go. So the actual price goes to 115, right? So we do know already what happens there. It's the same as this number here. They'll make $2.3 million. Now, proceeds from the contract. What does that mean is how much money is going to come in from those contracts that you shorted. So because you're shorting the contract, it's like if you're selling at $1 a pound because the contract is for $1. So we take the 50 contracts times the 40,000 pounds of each contract times the price you agreed to sell it to because you're shorting it. So $2 million is going to come in from you shorting the contracts. However, you have to deliver those pounds of meat, of beef, of cattle. So what happens is in order to do that, you're going to have to buy it at the market price. So now you're still doing the 50 contracts times the 40,000 pounds, but you're buying at 115. Now that's let's put a negative there because that's money going out. That's an cash outflow. So what happened is that you had to buy it at 115 and sell it for $1. So what you spent was more than what you got in the contract. Now that was the intent, because what matters is the end position. So we go ahead and add the cash inflows minus the cash outflows. You were able to lock in $2 million, which is sure is less than the 2.3, but much more than 1.6. Let's see what happens if it goes to 80 cents. So the live cattle value, we already have that number here, is 1.6 million. That's what comes in. Proceeds from the contract. Remember, the contract doesn't change. That's the whole point of the contract. So we can say that $2 million come in. Now, to cover the contract, you were able to buy it at a cheaper price and sell it for the $1, which is higher. So we take the 50 contracts times, and let me start it with a negative this time because it's going to be a cash outflow. 50 contracts times the 40,000 pounds times the 80 cents per pound you pay. So you only paid 1.6 million. So when we do the addition of all the cash flows, you end up with $2 million. So the point is that where the price goes up or the price goes down, you end up with the same amount of money, and you can count on that. The range becomes zero. You can lock in $2 million. Now, you see, hedging prevented you in this scenario to a potential downturn of $400,000 from that $2 million. However, you must understand that it also prevents you from the additional 300,000 you could have gotten if you would have speculated, if you took the risk. So this brings a risk of $700,000. 400,000 on the downside, 300,000 on the upside. Uncertainty. Here, there's no risk. You know you're gonna get $2 million no matter what happens. So this is useful in order to understand profits without risk versus the potential loss. And that's how this would work in this scenario. Now, in this scenario, we had a perfect situation where the contracts were a factor, a whole factor of the cattle. You can divide 2 million by 40,000 and get exactly 50. And they're both at 3 months. But that's not always, and they're both actual cattle. But here, let's look at a situation where it's not always a direct match. Here, we are going to assume that the period of 3 months works, so we don't put in too many variables. But the differences are going to be, first is that the asset that you're trying to hedge is jet fuel, but there are no contracts for jet fuel at the moment in the market in this scenario. So you look for something that is close to it, like heating oil futures. That was available, the closest thing you could find. The second challenge is that you're at 2 million, but the contracts are for 42,000 gallons, which doesn't exactly divide to a whole number. So then the question comes, what's the optimal amount of contracts I should buy and get into when I have assets that are not the same and the units do not match to a whole number. So information that is useful in order to get to that number that we need to see how many contracts should I engage in. So the spot price, meaning the price right now for jet fuel is $1.94. The standard deviation of that price is 0.0263. The period of months, but we're going to assume that they both are 3 months in order to avoid added nuances to this example. So then we look at the future contracts for the hedge. Now it's heating oil, which is not jet fuel, but it's 42,000. The future price in that contract is $1.99 per gallon. And the standard deviation of that price right now is 0.0313. So we need those standard deviations to get to the calculation we're going to get to. One more piece of information we need is the correlation between these two assets. This is jet fuel, this is heating oil. So they're not perfectly correlated, but they're very close. And here it shows with a 0.928. A correlation of 1 will be a perfect positive correlation. And you'll get that if you had jet fuel here and jet fuel here. And then we wouldn't need much of these calculations. We only have to deal with the difference in units. However, there are different assets with different prices and different standard deviations, and the correlation that is not perfect, but fairly high. So for this type of stuff, you do want that kind of correlation. You want it closer to 1. The closer to 1, the better. For this example, in this scenario we're going to set up. Now, there's a little different because in the previous example, the farmer was going to sell the cattle. Here, you're buying something, which is jet fuel. So the cash flows may look a little different, but it's fine. And it comes to the contract, whether you go long or short. Okay, so the idea is, well, how many contracts should you buy to settle, to hedge your jet fuel gallon? So let's start with this H. H is a factor that we need to know in order to, it's a factor I want to know in order to get the ultimate calculation that we need to do. All right. So what you do is you're going to take let me start the formula. You are going to take the spot standard deviation. You are going to take the spot standard deviation, and you're going to divide it by the standard deviation of the future contract. We're going to put parentheses here just for good measure. And all that is going to be multiplied by the correlation. And that's our H factor. Now let's get some other numbers in play here. Let's start with the value of the asset right now, which is 2 million gallons times the current price or the spot price. So that's how much it will be to buy that right now. Now let's check the value of one future contract. That one is the price of the future contract times the units, or the gallons in this case. So we start with the gallons times the price on the future contract, and that is the value of the future contract. Now, in contracts, future contracts can have no daily settlement, or after tailing is an expression used, or tailing is an expression used when there's a daily settlement. Now, that's something for another class when you look more into derivatives and contracts, but just to understand that they come in different flavors or with different characteristics. One that doesn't have a daily settlement situation, and another one where you may have tailing. So it's just a small change in the calculation, but can make a difference in the amount of contracts. So let's start with the daily settlement version. So what we do is we are going to start with that H factor that we have there, right? right? We're going to multiply it times the asset that you want to buy, which is 2 million gallons. And that is going to be divided by the gallons of each contract. So the optimal here will be 37.13 contracts. Now, you wouldn't be able to buy a fraction of a contract, so you'll have to do some rounding. So it might not be perfect now. So it is already not a perfect hedge. So it's not going to be work out exactly to the dot like the previous example did with the farmer, but this is as close as you're going to get. And then some rounding may throw you off a little more. The best you can do to lower the risk of loss. Now, here we go on the after telling. The calculation is a little different because if there's a daily settlement, what we do is we start with the same H factor, but this time we're going to multiply it by the values, the total values, not the gallons like we did in the previous example. So we take the value of the asset, divide it by the value of the future. And you know the 36.2. So 36 contracts will be optimal. Once again, some rounding and same effect. Remember, this is optimal. It means that you're not going to get a perfect hedge like we had here, but that's the best you're going to be able to do given the information you have. Okay, so that's it for this video. See you on the next one.